Right, welcome back to my channel. This is Felisa Strinke. Right, today we are going to be doing laws of indices. Right, this is Felisa Strinke. Welcome back to my channel. If you are new to this channel, please remember to subscribe to my channel. Just click the button below and subscribe to my channel. Join the Felimates Academy and let's learn together. So back to our laws of indices. Right, we have I can say 6 or 7 laws of indices that we use in everyday mathematics, right? Don't mind the letters that I'm going to use. I may use X, I may use M, A, or B. Just mind the concept, the law, right? So the first law, and don't mind the order, right? The first law is the law x to the power a times x to the power b, right? We have those two powers, we have those two, right, numbers, indices, sorry. They are multiplying x to the power a by x to the power b, right? We have those two terms multiplying each other. And the base is the same there. We have x here, we have x here. X to the power a times x to the power b. This is equal to x to the power a plus b. That's our first law, right? And we have the second law. This is number 2. If we have x to the power a divided by x to the power b, this is equal to x to the power a minus b. If we have two terms, and those terms are indices, we have x to the power raised to the power a divided by x raised to the power b. We have a division sign, and the bases are the same. We subtract the powers, right? So it's x to the power a minus b. Then the third law, jot these laws down. We are going to use them, we are going to apply them to some questions that I'm going to put up after summarizing the laws of indices. Right. The next law, any number raised to the power 0 is equal to 1. A to the power 0 is 1, 1 to the power 0 is 1, 2 to the power 0 is 1, x to the power 0 is 1. Anything raised to the power 0 is 1. Then the fourth law, x to the power negative a is equal to this negative. Most of us call it an inverse of x to the power a. This negative just means we have to invert this x to the power a, right? So it's 1 divided by this thing to the power positive a. The negative has gone. Once we have written this part represents our negative. 1 over that x to the power a. That's our fourth law. Then the fifth law, x, that's product of indices, right? X to the power a raised to the power b. We have double powers there, right? The first power and the second power there. So we are raising this is the product of indices. We are raising to the power a, and then that x to the power a is then raised to the power b. So this simplifies to x to the power a b, right? Number 6, fractional indices. This is product of indices. Then fractional indices, x to the power a over b. X to the power a over b is equal to the bth root of x to the power the numerator, right? Or the bth root of x all raised to the power a, right? So it's the bth root, the denominator determines the whatever term, right? The whatever root, so the whatever root, so it's the bth root of this x to the power the numerator there, right? So we have these 6 laws of indices. I hope I haven't left out any law there, right? So we have those 6 laws of indices. Can you please jot them down? We are going to use them, right? We are going to use them, right? And now I'm now going to use past exam questions to apply all these laws of indices, right? I hope you have jotted them down. We are now doing the application part, right? We are now doing the application part. Remember to leave a comment, subscribe, and share my videos to your colleagues, guys, right? Share my videos to your colleagues, leave a thumbs up, and make use of the comment section, right? Make use of the comment section, guys, right? The first question is a June 2018 question from a paper 1 question paper, question number 4. Right, evaluate the cube root of 0,027. Right, that one, let's leave that one out. Evaluate 1 and 7 over 9 to the power half. Right, evaluate 1 and 7 over 9 all to the power half. All this is raised to the power half. So the solution, so the B part, evaluate this, and C, we are to evaluate 3 to the power 0 times 3 to the power -2. Right, that's our C part. The B part, 1 and 7 over 9 to the power half. 1 and 7 over 9 to the power half. First, we are going to convert this to an improper fraction. So we multiply this by 1, it's 9, then we add that 9 to 7. So it's 9 plus 7, it becomes 16 over 9 to the power half. Right, remember we said these are fractional indices, right? The power is a fraction. So this is the second root. The second root is just the same as the square root of all this. 16 over 9 raised to the power 1. Right, this to the power 1 is just the same as at 16 over 9. So the square root of 16 over 9, we can, if we are dividing, we can distribute the root sign, distribute it to the numerator and to the denominator we are dividing, right? So it's the square root of 16 over the square root of 9. What is the square root of 16? The square root of 16 is, this square root of 16 is just the same as, we want a number that if we multiply by itself, it's going to result in 16. What is a number that if we multiply that number by itself, it's going to be a 16. So the square root of 16 is 4. 4 times 4 is equal to 16. So the square root of 16 is 4. Right. So the square root of 16 is 4. And the square root of 9. What is a number that is what is a number such that if we multiply that number by itself, we are going to get a 9. It's 3. Right? 3 times 3 is 9. So the square root of 9 is 3. Then this is 1 and that. Right? That's how we solve that question. Part C. Remember to subscribe to the channel. And please, we have some live lessons. Maybe we have in a week we have 2 or 3 lessons, live lessons. Please join my live lessons. Join our live lessons so that we can interact more during those live lessons, right? See, 3 to the power 0 times 3 to the power negative 2. Any number to the power 0, it's 1, right? Times 3 to the power negative 2. This is equal to 1 times this is 3 to the power negative 2. And we have a negative power there. We said a negative implies 1 over this number to the power a positive 2. So it's 3 to the power 2. This becomes 1 over 9. Or we can solve it this way. We can solve it some other way. We are multiplying, these bases are the same. We have 3 there, 3 there, and we are multiplying, so it's 3 to the power this plus this. 0 plus minus 2. So it's 3 to the power, a plus and a negative, it's a negative. So 0 minus 2 is a negative 2. And this negative is 1 over 3 to the power 2, which is 1 over 9. Right? So that's how we solve those questions. That's how we solve those questions. Moving on to some other question. We have in November 2017 question 3 paper 1. Simplify 2 plus x to the power 0. 2 plus x to the power of 0. This is the first question. The second question, 3x to the power negative 2 all over 3x. Right, our solution. The first question, we said anything raised to the power of 0, 2 plus x is raised to the power of 0. All this is raised to the power of 0. So anything raised to the power of 0 is 1. So our result there is 1. Then number 2, 3x to the power negative 2 over 3x. Right. Please, this negative 2 is a power of x only. Right? X is raised to the power negative 2. 3 is not raised to the power of negative 2. If it was raised to the power of negative 2, we would have brackets there. So this negative 2 is just affecting our x only, right? So we can divide the 3 into 3, 1 into 3, 1. So we now have x to the power negative 2 over x. This is just the same as x to the power negative 2 divided by x. And this x is just the same as to the power 1, right? So we are now dividing. These are equal, at the same basis there. So it's x to the power negative 2 minus 1. So it's x to the power negative 3. You can leave it like this or simplify it to 1 over x to the power of 3. Right, so it's now simplified. Let's move on to another question. We are going to do as many questions as we can. Right? This is a November 2013 question 6, paper 1. Simplify 3 to the power 3, A, 3 to the power 3 to the power 4 over 27 to the power 3. 27 to the power 3. Then B, 4x squared y to the power 6. 4x squared y to the power 6, all raised to the power half. Then C, x to the power 0 divided by x to the power negative 2. X to the power negative 2. These are 1 mark, 1 mark, 1 mark. Right? So our solution, solutions or solution, whatever. Right, we have 3 to the power 3 raised to the power 4 over 27 to the power of 3. Right. By manipulation, the 3 to the power 3 is just the same as 27. But we can also simplify this part. 3 to the power of 3 times 4. We have 2 powers there. 3 to the power of 3 is also raised to the power of 4. So we multiply the powers. It's a product of indices, right? Over this 27 is just the same as to the power of 3. Right? To the power of 3. Are we together? Are we together? Right, so it's 3 to the power of 12. 3 to the power of 12 divided by 3 to the power of 9. So this is just the same as 3 to the power of 12 divided by 3 to the power of 9. So we have the same basis there. So this is 3 to the power of 12 minus 9. This is 3 to the power of 3. 12 minus 9 is 3. So 3 to the power of 3 is 27. Right? So that was our A. For the B part, right? B. 4x squared y to the power of 6 to the power of half. Now, this 4 is raised to the power of half. This x squared is raised to the power of half. Y to the power of 6 is raised to the power of half. Right? So we can distribute our power there. These things are multiplying each other. These terms are multiplying each other. So we can safely distribute those. If the terms are multiplying or dividing, we can distribute the power, we can distribute the root, we can distribute anything, right? So we are distributing that half, sorry. So it's 4 to the power of half times x squared to the power of half times y to the power of 6 to the power of half, right? This becomes, remember, these are fractional indices. So it's the square root of 4 to the power of 1 times this product of indices, right? We raise to the power of 2 and again raise to the power of half. So we multiply 2 times half. What is 2 times half? It's 1, right? 2 into 2, 1 into 2, 1. 1 times 1 over 1 times 1, it's 1, right? So 2 times half is 1. X to the power of 2 times half. Times 6 times half is 3, right? So it's y to the power of 6 times half, right? I don't know why I'm simplifying 6 times half there. should have simplified that. Okay, square root of 4 is 2 times 2 times half is 1, so it's x to the power of 1 times y to the power of 6 times half is 3. So it's 2xy cubed. That's the solution to part B. Then we move on to, if I'm rushing through, you can pause or you can play back so that you get to understand bit by bit. Part C. You can play back the video, you understand bit by bit. X to the power of 0 divided by x to the power of negative 2. Right. The bases are the same, so it's x to the power of, we are dividing, so we subtract the power 0 minus this power negative 2. So it's 0 minus negative 2. So it's x to the power, this negative and the negative, it's a positive. So 0 plus 2 is a 2. So it simplifies to x squared. We are done with that question. Right, we are done with that question. Let's move on. Where are you, my guy? Right. This is what I was looking for. Evaluate A, 3m to the power of negative 5, 3m to the power of negative 5 times 2m to the power of 5. I'm more interested in the B part. Question June 2011, question 11, paper 1, 4 over 9 to the power of negative half. I'm more interested in this part, part B. It's worth 2 marks. That's right, that's what I'm most interested in. Right, A, 3m to the power of negative 5 times 2m to the power of 5. Right, that's our question. Here we are going to multiply 3 by 2, this by this. Right? This is just the same as 3 times m to the power of negative 5 times 2 times m to the power of 5. So we are going to multiply this on their own, this on their own. So it's 3 times 2 times m to the power of negative 5 times m to the power of 5. So 3 times 2 is 6 times m, the same base, we are multiplying, so we add the powers. M to the power of negative 5 plus 5. So this is 6 times m to the power of minus 5 plus 5 is 7. So 6 times any number to the power of 0 is 1. So our result is 6. B. B part. I'm interested in the B part. 4 over 9 to the power of negative half. Right, remember I said any power that is a negative, it implies 1 over. Right, so on this part, instead of having 2 fractions, 1 over 3 times, we are going to divide. 1 over is just the same as 1 divided by 4 over 9, but now it's a positive half. 1 over 3 is just the same as 1 divided by 3. That's what we've done there. 1 over 4 over 9 is just the same as 1 divided by 4 over 9. But now we have a power that is positive. Right? So we now simplify that. 1 divided by, we have a fractional index there. Right? So we are going to find the second root. The denominator is a 2, so it's the second root, which is the square root, right? So the square root of 4/9 raised to the power of 1. So it's 1 divided by square root of 4 to square root of 9, 3. Right? So this is 1 times we invert. Changing from a division to a multiplication, we are going to invert the second fraction. The moment you change that division sign to a multiplication, you are going to invert the second fraction. So to invert the second fraction, we are going to have 3/2. So 1 times 3/2 is 3/2, and 3/2 is 1.5. So that's our final answer, 1.5. Right. I think I've tried my best, but we still have questions involving. Okay. We still have questions involving laws of indices, but they are now equations. Right, we want to solve those equations. Right. Solve the equation 3 to the power k. Okay, let me start with this one. From simple to complex, right? X to the power 2/3. X to the power 2/3 is equal to 4. 2 marks. We have to solve that equation. It's 2 marks. So it's 2 marks. It's in November 2019, question 20. June 2019, question 20. It's a paper 1 question. Right. When solving for x, we want to remain with x on this side. X alone. Right? X to the power 2/3. X to the power 2/3 is equal to 4. We want to remain with x on this side. Right? To remain with x on this side, we just introduce another power. That is an inverse of this. That is a reciprocal of this, right? So we raise all this to the power 3/2 and raise all this to the power 3/2. So that if these two multiply each other, we get a 1. Right? We want to eliminate that power. Right? So we now have x to the power 2/3 to the power 3/2 is equal to 4 to the power 3/2. This is product of indices. We are now multiplying 2/3 times 3/2. You just introduce a power that is a reciprocal of the existing power, right? So 3 to 3, 1 into 3, 1. 2 into 2, 1 into 2, 1. So we remain with 1. The x to the power 1 is just the same as x. So we now have x to the power 1 is equal to, this is a fractional index, the square root of 4 to the power 3. Square root of 4 to the power of 3. We can always write a 2, or we can always leave a 2. The square root is just the same. This is just the same as this. But you can't leave out a 3 for a cube root. A cube root, you can't leave out a 3 and say this is the same. This is not the same. This is a square root, but this is a cube root. But this one is a square root, this one is a square root. So I think the confusion is cleared there. It's been cleared. We now have an x there is equal to, the square root of 4 is 2 to the power 3. So x to the power 2 to the power 3 is 8. So our x is equal to 8. Right? That's how we solve that equation using our laws of indices. Right? Another question that involves equations 3 to the power k. So for k, 3 to the power k is equal to 81 squared times 3 to the power 5 all over 3 to the power 11. Right. We want to solve for k then. Solution. We have 3 to the power of k is equal to 81 squared times 3 to the power of 5 over 3 to the power of 11. So 3 to the power of k is equal to 81 is just the same as 3 to the power of 4, right? So it's 3 to the power of 4, that's our 81. Then squared times 3 to the power of 5 divided by 3 to the power 11. So we now have 3 to the power k is equal to product of indices. So we multiply those powers, right? So it's 3 to the power 8 times 3 to the power 5 divided by 3 to the power 11. So we now have 3 to the power k is equal to, we are multiplying these, the bases are the same, so we now have 3 to the power 8 plus 5 over 3 to the power 11. Right? 3 to the power k is equal to, what is 8 plus 5? 13, right? 8 plus 5 is 13, right? Yeah, right. So it's to the power of 13 over 3 to the power of 11. So we now have 3 to the power k is equal to 3 to the power 13 divided by 3 to the power 11. Going back to our laws of indices, we now have 3 to the power k is equal to 3 to the power 13 minus 11. So 3 to the power k is equal to 3 to the power 13 minus 11, 2. The bases are the same. 3 is equal to 3. Therefore, 3 is equal to 3. Therefore, k is equal to 2. We have solved for k. So our k is 2. Let's have another question. Let's have another question. The last question. Please remember to subscribe to my channel, like and share my videos with your colleagues that may be in need of that certain video. Right. We now have 4 to the power 4. Solve for n, right? Solve the equation 4 to the power 2n minus 3 is equal to 8. That's a June 2018 question 8b. That's a paper 1 question paper. Right. To solve this, we have a solution. Right, these 4. Right, we want to manipulate our basis thing. This is just the same as 8 to the power 1. We want to manipulate our basis so that they are the same. So we can change this 4 to 2 to the, sorry, let me write out the question. 4 to the power 2n minus 3 is equal to 8. This 4 is 2 to the power 2. That's our 4. This is the 4. To the power, this one, 2n minus 3, right, is equal to 8 is 2 to the power 3. We are raising 2 to the power 2 and again to the power 2n minus 3. So it's a product of indices. We multiply this by this. So it's 2 to the power 2 times 2n minus 3. is equal to 2 to the power 3. So 2 to the power 4n minus 6, 2 times 2n is 4n, 2 times minus 3 is negative 6, is equal to 2 to the power 3. 2 is equal to 2, therefore 4n minus 6 is equal to 3. Then you can now solve for n. Right, I want the result in the comment section. Find the value of n there. Find the value of n. Please remember to find the value of n. Right. I want to respond to that other question that I left on this channel some other day back then, right? It was a question on solving simultaneous equations using the matrix method. I think, let me, I will upload a video tomorrow on that aspect, on those questions that I left out, right? That I left for you to solve and respond them in the comment section. I saw some answers, some were correct, some were partially correct. Right? So for today we are done with our laws of indices. Please remember to subscribe, like and share my videos to your colleagues. And I'm liking your cooperation, guys, your comments. I will always try to update my responses to you in my comment section. Love you, thank you, take care, bye-bye.